Doing? Good to see you. Hey, Hayden and Cadence, how are you guys? Good to see you. Did anybody have pizza for lunch? I had noodles and broccoli on what was it, a cheese sauce. Kind of like pizza. Noodles, pasta. Good, I'm glad you're good. Hey, Sabrina. I had chicken and broccoli. Oh, good, good. I had salad. Ooh, good for you. Good for you. Lots of veggies. Good afternoon. How's everybody feeling? My last two classes this morning, they were just so tired. Tuesday tired. Everybody tired today? You're good though, huh? Okay, not too tired. It's great because it really does zap your strength. Yeah, a little. Yeah, it does zap your strength just sitting here. It's like you got to take a stretch break and you got to get up and walk around. It's a good thing I have to go to the bathroom so often. I have to go upstairs, downstairs. So, do you? What do you miss the most about school? Oh, okay. That's interesting because our when I was teaching eighth grade, like after sixth grade, they didn't let you do the playground at all. But the eighth graders in my school, they really petitioned so that they could be outside and do some stuff like that. Yeah. Yep. In person. Yeah. What I don't miss though is we had lots of fights. Lots of fights. That's my students were from the city of Detroit, and they were in fights a lot. They just he said, she said stuff, um, that kind of stuff. Yep. Girls. I hate to say this, but the girls were the fighters the most. They were the fighters. Yep. Yep. Yeah. Yep. They were fighting, and then I've been hurt by fights. It's like I try to break it up, and somebody tries to hit the person next, right behind me, like I'm between them, and it's most of the time it goes like this. It's like, I didn't mean to hit you, Mr. Gale, I was trying to hit her behind you. It's like, well, that was why I was there. My glasses would go flying and so forth like that, and so I get clothes ripped. And then when in high school, my gosh, in high school, you didn't want to get in between there. Somebody was taking one of my high school students was I liked her a lot, but she would take a locker, a metal lock, and beat the heck out of the person with it. So yeah, I don't miss those days. I don't miss it as a teacher, that's for sure. You know, and then everybody's video, it's like, hey, look at this, look at that. So I think we're good. We're good. I have to say, we're really good. I think feeling pretty good about being here, and not, the worst thing that happened is somebody calls you out, on your name, so yeah, no, metal, right? There's a metal lock going over somebody's head. Yeah. I had a Let's see, what was it? I had a student on last day of school came to my door, knocked on the door, opened the door, and then threw water in my face. Like what? How respectful is that? Like what were you thinking? So, well, it was last day of school. How are you? Good for you. Can see. So we do really need to get outside and get some physical activity. That's for sure. So you guys remember, if you do offline tracker stuff, if you take a walk in the woods or go do some physical stuff, let me know. I'll give you some offline tracker stuff. But this is a good place, especially it's uncertain times, unfortunately, and things are not so good when it comes to being in person. You never know when somebody wants to, say something mean to you, like to a teacher. I can't believe it, right? Or to, um, somebody, and even Instagram. So I got mad at you because you put something about me on Instagram, right? Yeah, with water guns. Okay. Yep. I used to have people pull people's braids out. So, all right, just to let you guys know, hey, we're back. So tomorrow, Wednesday is tomorrow, right? Wednesday, 9:20 is async day. All right, so because I have to take my mom back to um, her house, and I'm going to use the half of the afternoon to call parents. So you will see a video. I've got a video for you um, on building an atom. It's cool, kind of fat assignment. It's a bonus, building an atom. We'll talk a little bit about it. Hopefully, at the end of the hour, building an atom. There is a bonus activity. Not very long, but it's like 25 points. So if you want to have more points because I'm gone, for sure. Um, we used to have lace fronts in the hall. What is a oh is that lace? What is that? What's a lace front? Hey, Akila. Oh, a wig. Oh, okay. Cool, cool, cool. So you guys know that. All right. So we're gonna get started. I got a lot of things to do today. We're gonna do that half and half split today. So let's do this. Thank you guys for sharing your thoughts about school, the good, the bad, and the ugly. Uh-oh, the ugly parts, the ugly parts. And I'm going to turn my face to black screen. Yo, bye-bye. I thought I turned it. Nope. There we go. All right, so let's get in there, ladies and gentlemen. Link is copied. I'm going to yeah, it hurts when you get your wig pulled off there. So I'm going to do here. Okay, there we go. There's the link. I'm going to put that in the shared notes as well. I'm glad you guys are here, not in public school and being affected by everything that's going on. So, again, I think this is a great place for you guys. You guys have a lot of energy. Let me go and all right. So, okay, we've got 9 people. Great. Great. You guys are just the best when it comes to this stuff. Okay, so we're going to split classes as I said. All right. All right. Keela, Adriana was in your classes in school. All right. So, okay, so we're talking about the atom, right? Can understand why atoms make up the universe. I'm going to listen in class, going to talk about subatomic particles and just the basic stuff about atoms. We did the pretest. We looked at the video. Okay, so let's take a quick review. I'm going to ask you guys that are in here to take a little quiz on some of these questions. Neutron, neutral particle, no electric charge, helps the nucleus in the atom. Because if you think about it, all these positive um, charges in the nucleus, they repel each other, and the neutrons are helpful for keeping those together. The heaviest of the particles in the atom, heavier than the proton, but not by much. They are in the nucleus. The electrons are outside the nucleus, right? They're orbiting around in a orbit shell or orbital level. They have a maximum in the first shell. It is 2. Those are the weakest electrons. They are closest to the nucleus with the protons. They're attracted because of the negative and positive attraction. Second shell, a little further away, can hold up to 8. Third shell can hold up to 8 or 18. They move rapidly. So, of course, this is a 2-dimensional version. 3-dimensional version is more like a cloud. They go all over the place. Their mass is so small that it's considered insignificant. It takes about 2,000 of the electrons in order to make the mass of a proton. But the electrons are important because they are involved in chemical bonds. The protons, of course, are in the nucleus. They're the positively charged, but they are the DNA. The DNA meaning that they identify what the particle is, what the element is. One can be hydrogen, two protons can be helium, and three protons can be lithium. You think about it, hydrogen is a flammable gas. Helium is a gas that is not flammable, and it can use in balloons. And then lithium is something used in the batteries. It's a metal. So just by adding a proton, and all that happens in the sun. The sun started all this stuff out, started combining elements like hydrogen into helium, right? So they contribute to the atomic mass. And when we're talking about electrons, when we're talking about a neutral atom, the protons and the neutrons are equal. So they match each other out, so they cancel. So one proton, one electron cancel each other out for 0 electron charge. Okay, so here is your question. What subatomic particle has a neutral charge? Can you vote for me, please? Vote in there. If you can do this, I'll put it in the Pear Deck. I'll start a poll here as well, see who's smarter, the people in the Pear Deck or the people in the, so neutral charge, A, B, or C, neutral charge, N-E-U-T-R-A-L. Let's see what we got here, A, B, or C. What do you think, people in the starting the poll? If you're not in the Nearpod, or sorry, Pear Deck, go ahead and vote here. Which is it? Neutron? Is it A, proton? B, neutron? Is it C? All right, so we got a few people that are saying it's that. Let's see what the people, see if we win against each other. So let's see here. Okay, so show responses. 13. All right, looks like most people said neutron. Oh, good. You guys are about the same. Most people said it's the neutron. See, look at that. 10 out of 13. You guys switched over. I didn't say that. Oh my gosh, you guys are competing against each other. Funny. All right, so neutron is the neutral, 0 charge. If I say 0 charge, that's neutral. Oops, sorry. Go back here, hide responses. Okay, let's do this next one. See how the group is on this one. Subatomic particle with a positive charge. Let's do this one for the people in the class that are going to compete. Start a poll, A, B, C. All right, positive charge, positive, P-O-S, positive. Which one? Proton, neutron, or electron? What do you think? Proton, neutron, or electron? See how many people vote in this one. So remember, don't cheat. Don't vote in both. All right. So if you're not doing it in the Pear Deck, do it on the Nearpod, or I'm sorry, do it on the poll in Big Blue Button. So proton, neutron. Okay, so most of you are saying, so let's see what this one says here. We have 9 responses here, 10 responses. Okay. All right. It looks like about the same. Everybody said proton. And a couple people said electron. Remember, electrons are the electrical. They are the negative charged ones. Okay. All right, let's do one more here. Subatomic particle with a negative charge. Only one left. Let's do this one. Start a poll. See if everybody's got this one. Start a poll. Negative charge, NEG charge. Start a poll. Let's see if we can compete against each other. Who thinks it's a proton, a neutron, or electron? Okay, so proton, neutron, or electron. Uh-oh. Looks like I haven't fooled 10 people. Uh-oh. Let's see. You got 9 people on this side. Let's see if we can get 10 on this side. Oh, somebody said a neutron. You guys are better in the chat here. It's a electron. Somebody wasn't paying attention, or they misclicked. That's probably what happened. They misclicked. I can't believe it. All right. Subatomic particle not found in the nucleus. Okay. So publish the poll here. not found in the nucleus. Start a poll. Not found in the nucleus. Not found in the nucleus. Not found in the nuke. All right, start this one. Which one? Proton, a neutron, or electron? Not found in the nucleus. Not found in the nucleus. This is a little harder problem. So the thing that spins around outside, which one that spins around the nucleus? It's not found in the nucleus. Okay, is it proton, neutron, or electron? Okay, we got some people thinking, scratching their head, probably scratching. I'm scratching. Okay, let's see. We got 10 people here and 10 people, oh, only 8 people here. So let's show the response here. All right. Oh, we got a whole variety. Most people got it right. It's electron. It's electron. Okay. Most people got it right here. 7. Some people have to look at their notes. Really have to look at their notes. All right. And you've seen this in science class probably a few times. I hope. Okay, so here's the periodic table, right? You've got your atomic number, which is the number of protons across the top here. Hydrogen is 1, helium is 2, lithium is 3. So you're going across the rows, or the periods they call. Up and down are the families. Those are the columns. But if you're going across the rows, it gets bigger to 104 or 103, 118 actually. All right, so we usually worry about the first 20. All right, so atomic number is the atomic mass versus the atomic mass. So atomic number is the protons, right? Protons. Let me type this in here. Atomic mass is the protons plus the neutrons, right? And the atomic number is just the protons. So that's the difference. Now, remember the protons are how many protons, and that tells the DNA tells me what it is, right? Tells me what it is. Okay, we use a capital letter for our first letter if there are 2 letters, and then we use an uncapitalized or lowercase in order to do that. If we do this and we do M and capital O, that's telling us that we have 2 elements bonded together. So M small o, capital C, carbon. I honestly always see this question in which of these is an element, and they'll go like this: capital C, capital O, and capital C, lowercase o. This is the element right here. This is 2 elements. All right. So because the elements are of different forms on the Earth, that means that this number down here, 95.94, some of them have more neutrons than others, right? And then they average those out. They find out how many approximately out of 100% there are, and they average those out. So that's why the number is not whole, right? So we've got atomic number is the smaller number, most of the cases. 6, hydrogen, sometimes they have 1.09 for the atomic mass, and then they have 1 for so it could be the same number up and down. But remember, mass is protons plus neutrons. Atomic number is just the protons. Okay, name the element with 26 protons. Okay, so for those people, I'm going to go back here. So tell me, let me give you this P table here. So look in and this is a private chat thing, please. P table. I'm going to give you this. All right, P table. Tell me from that periodic table. All right, in the private chat, tell me what is element that has 26 protons. 26 protons. Okay, here is the P table. Control V, and there's the P table. Naomi, thank you. All right, you got it. Thanks for that private chat. That way you're not giving it away. Do it in the private chat. Tell me what element is in 26 protons. 26th one. So if we look at this, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We go around the rows. So which one is it? Hey, Aquila. Yes, you're right. Farium. Farium. Thank you, Raven. Thanks, Aquila. Thanks, Naomi. Let me see how many of these people have done this. See how many people got this right. Let's go double check. All right. Show responses. Iron, iron, iron. We got 4 irons. Okay, so you need to be able to look at, hey, Adriana, you need to be able to look, yep, and Fe. Fe is an old name for iron, ferium. So that's why it's Fe, not I, but that's probably because iodine came after iron. So they said, let's change it. Let's call it ferium. It's a Latin name. Okay, so all right, so most people got iron here. Looking at, so that's the part here. Okay, so all right, so those people, we're going to take a few minutes here. Those people that did the class with me. So let's see. C through M. C through M, you're going to do this Ed puzzle. Okay, you're going to do this bonus Ed puzzle. C through M. Okay, I'm going to put this in the chat. C through M. So C through M. You're going to do this Ed puzzle, right? Video Ed puzzle. C through M, do that. Okay, everybody else, N through W, continue on with me. We'll take a quick stroll through here. So if you, unless of course you didn't do this yesterday, you can, if you didn't do it yesterday, you want some help on this, you can stay around with this. But let's do this together. I'm going to use my P table here. Let me do this. I'm going to put that right there. And then I'm going to do my P table here. There we go. Okay, so let's go and figure this out. Okay, so protons. So it's kind of hard to tell in this particular case, but if you look, we can count the electrons, 2, 4, 6. So remember, we're looking for a neutral atom. So we're going to say 6 electrons, which gives us 6 protons, because remember, plus 6 plus a negative 6, they cancel each other, give you 0, 0 charge. So we're looking for that. And we usually look at neutrons and we say there's 6 and 6 and 6. Access denied. Oh no, let me double check. Okay, thank you for that. Let me, maybe I forgot to publish it. Let me show, well, let me go here. All right, so let me go here. Let me get that. Thanks, ladies and gentlemen, for telling me about that. Access denied. Oh no, don't say it that way. It sounds so horrible when you say access denied. I tell you. Oh, you know what I did? I did Power School 6. That's what I did. Not that funny. Let me go back here. Okay, so let me go back a second. Yeah, I gave you Power School 6. I forgot where I was. Let me go this way. I'll go backwards. Clone that. Take that out of there. Yep. Okay, here we go. Power School 5. Yeah, see, that's terrible. I used to have no problem with that because we had one class all the time. History. No, that's not it. That is not it. Oh, that's what happened yesterday. Gosh, and I didn't fix that. I'm so silly. Can't remember a thing. Can't remember what's happening. Okay, here we go. History. Let's try this again. No. I want to go to modules. That's what I want. W5. Where are you? There we go. Control copy. Now let's do this. Control V. There we go. Try that. See if that works for you guys. Thank you so much for getting in there. Does that work? Let me know. Oh, great. Thanks so much. All right, so 6, 6, and 6, carbon. That's what I was trying to get at, carbon. So let me go back to my P table. Yep, carbon is 6 protons. And that's basically what we're trying to do. If you look at this particular table, 2 is the number of electrons in the first shell, 4 in the second shell, because 2 is the maximum number. There's 12.001, right? So that means there's 6 protons and 6 neutrons. 6 is the protons only. All right, let's go to the next one. Okay, let's go to the next one. All right, so here we have, this one's easy to see. Got 3 protons, 3 neutrons, 3 electrons. Okay, let me do this. I got to see who's here to give them credit for this. Can I not do that? Nope, I can't do that. 333. I got to do this to get this first. Go look at my dashboard, see who's here. Say hello to everybody that's working out. Yeah, that's true, isn't it? That what I think what that's true, Jaden. That's what happens with that. What they say is that um, we got a protein overload, so you got to eat light. 3, 3, 3. Anybody figure out what it is? Looking at the P table. Anybody figure out where it is? All right, week. Okay, let me get the names of the people that are helping me out here. We only had 2 people last time. Hey, Kendall, thanks so much. All right. All right, where are you? There's P6. Not on P6, I want P5. All right, P5. P5. Kendall is helping by participating. Keela is helping. All right. And we've got Kendall's helping. I said that before, but then somebody else. There we go. Thanks, Kendall. And we've got Leiden. All right, I got to change the cover over here. Change it over to the other side. All right. Okay, and then we got Raven. Thanks, Raven. And then we got Ryder. Thanks, Ryder. Thank you. And we got Sabrina. And we got Steven. Hey, I think you guys are the same guys I had last time. You guys are the one. Did you guys already do the video? Did you guys already do the video? Did I get it wrong? Did I have the scientific? Let me see. Oh, okay. You already did it. All right. Okay. All right. So you guys are probably pretty good at this then. All right. So this is lithium. Okay. Lithium. Okay. Yep. Lithium. All right. Again, we can count the electrons. We got 2 in the first shell, 8 in the second shell, and 1, 2, 3, 4, 5, 6, 7. So total of 15 protons and electrons and neutrons. Okay. Yep. And so that would give us Wait a minute. 8, 10, 17. What am I talking about? This is not 8, 15. So let's try that again. 17, 17, 17. Anybody remember what that one was on the periodic table? So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We got chlorine. Okay. Yep, chlorine is right. All right. We write that capital C, little l. All right, so let me see if there's anybody in here that did not do it yesterday that, oh, okay. Raven didn't do it yesterday. Okay, cool. All right, so Raven is the only one that didn't do it yesterday. She was doing the video. All right. There is chlorine, 17, 17, 17. All right, this one, you can see the different configuration here, but you can also see that the protons are 8. You can count them in the nucleus because they're big enough. And again, you do that. It's nice when they're big like that, but when they get to be really big, electrons 8. See what 8 gives us. 8 gives us oxygen, and you can see that 8, total of 16, which is the protons and neutrons, 2 in the first shell electrons, and 6 in the second shell electrons. The capital O for oxygen. Thanks, Leiden. Thanks, Raven. Thanks, Aquila. Thanks, Stephen. Yep, 8, 8, and 8 is oxygen. Now, here's one that's a little bit different. They say this out here. They give you the numbers here. So they got protons as 13. They have neutrons as 14. So that's unusual, but that happens. And electrons are going to, because it's a neutral atom, we're going to have 13 as well. 13. All right. And then the element that we're looking for is the number of protons, not the number of neutrons. Number of protons. So 13 is aluminum. We got 2, 8, and 3. So 10, 13, that's aluminum. And the interesting thing about aluminum is that it has sometimes more neutrons than protons. So A, capital A, small l. And let's take a look at what they say here. Okay, higher neutrons means something we will discuss next week. We'll see that here in a few minutes. Okay. So if I ask you what 68 element 68 is, protons, now notice the periodic table is arranged from left to right with the number of protons. Hydrogen is 1 proton, helium 2 protons, 3, 4. Go back to the left. Lithium is 3, 4, and then there's this big abyss, this kind of space in between, and then there are 5, 6, 7, 8, 9, 10, and then go back over. There's a reason for this, and we'll get that when we get to the periodic table. So 68. Okay, so they made this more condensed so it fit on a page. And they took this piece out and put it underneath. So 68 is ER. Yep. Number 1 is hydrogen, right? 1 proton. And there is a problem with, let's see, 71. So 71 is luteum, Luteitium. And then 42, and you can just use the little letters on there if you want to. And then 42, where is 42? 42 is molybdenum. 42, just MO. Okay. So if you want to look for the krypton, so krypton is Kr, and you're going to put down 36 as the number of protons. Oxygen, there was a mistake in here. My friend did oxygen as 16, but it's 8 protons. And carbon is 6 protons. Thanks for keeping up with me. All right. 8. So krypton is 36. Oxygen is 8. And carbon is 6. All right. Okay. All right. And you might be looking at it yourself, the numbers as well. Okay. And again, like I said, I'll show you the next slide, and that'll tell you that he accidentally put the atomic mass in here. So ER, H, L, U, and MO, 36. This is supposed to be 8. And we make those kinds of mistakes as well. 6 and 77. Oh, I didn't even see that on my page because there's too much there. Okay. Okay. So let us go to this new assignment. I'll show you what's in store for you next tomorrow. So we'll get a little practice on this so you can do this tomorrow because we have about a half an hour left. So let me get this going for you. All right, let's go here. New tab. Nearpod. Okay. Live participation. Start a new session. Okay, here you go. So this is what we're going to do tomorrow. You guys are going to do it in as a assignment here. This is kind of cool. This is build an atom in PhET. Okay, and I'll show you how to do this. Okay, tell me when you're in, and then we'll work on those assignments together. Anybody can join on this one and the Nearpod. Let me clear out the chat here, and then I'll just do this again on the Nearpod. So just trying to get you updated into tomorrow's assignment. So if you could do that. Okay, so you can see, if you play around with this, you can see that if you add a proton, now you've got hydrogen. So I had this atom had no protons, so it was nothing. So now when I hit this, I'm going to hit stability here, stable or unstable. So I have hydrogen. I have a positive charge. There's no electron to see if I add an electron, it's 0 charge because they balance each other out. But if I take the electron away, it's a positive charge. That makes sense because the hydrogen is positively charged. The nucleus is positively charged. If I add 2 helium, it goes to helium. So that's the, remember, this is why the proton is that part of the element that makes its DNA, tells it what it is. But notice it's unstable. Okay, so if I add a electron to it, notice the charge goes down. I can get this to a neutral atom, but it's still unstable. So tell me, for those people that are doing this, how do I get this stable? What can I add to this to get this stable? So tell me in the chat, what do you think? All right, how many? How many neutrons do I have to add to get it stable? 1. Let's take a look. You're right. Okay, so that's what the job of the neutron is to stabilize the atom. So that's why hydrogen didn't need one, but helium sure did. Okay, so let's try another one. So I'm going to hit the reset here, and then I'm going to do this. Okay, and I think you can go, let's go to the next one. Let's go to lithium. How many protons do I need to make lithium? Tell me in the chat here. How many protons do I need to get it to go to lithium? All right, thanks, Naomi. You are absolutely correct. So we have to do 1, 2, and see what happens. 2 makes it helium, 3 makes it lithium. So click on the stable, unstable. What am I going to add to this to make it stable? What am I going to add to this to make it stable? Three more protons. Okay, if I add 3 more protons, well, nope. What happens is it turns to beryllium. We want to keep it lithium. We got to keep it lithium. Neutrons. How many neutrons? 3. Oh, okay. That's what you were talking about. You're talking about 3 neutrons. 2, 3. Oh, yeah, there you go. Now notice the mass is 6. You've got 3 protons up here, 3 electrons. Okay, how many electrons do I need to add to make this a charge of 0? 3, says Elroy. Let's see what he's right. There's 1, 2, and I'm going to try to add it to the second shell, but notice it doesn't do it. Neutral atom. How about if I need to make it a positive 1? Yeah, you know, we do have, Jaden, we do have to repeat, right? How many more electrons do I need to do or subtract to make this a negative 1? Yeah, negative 1. And you'll notice, oh, it's negative 1. You have a negative 1 charge. It's called an ion. Okay, so let's do this together, ladies and gentlemen. Let's do this next one. This is kind of like a precursor to the homework or the assignment tomorrow. Let's go next door. All right. Okay, so let's do this. I'm going to give you the link here. Let's go back to the PhET. Now, if you like this PhET, this is really a lot of fun. There, again, like my idea of fun, right? Mr. Gale's idea of fun, not anybody else. Okay, so there's 3 things you can do with this. There's a game, there's a symbol, and then there's the atom. Okay, so I'm going to give you this link. Okay. There we go. There's the link to this one. So if you have both of them together, so I'm going to do, where are you, Edpuzzle? No, Nearpod. So I'm going to do this. I'm going to make this small. And I'm going to make Nearpod over here. There we go. Okay. So let's try to do this together. Let's try to figure this out. How many protons for beryllium? Anybody figured out? You should, yeah, collecting rocks is a lot of fun. That is a lot of fun. So how many protons to make beryllium? Anybody know? Got to make sure that this goes down, and it's stable. 4. All right, 4. So 1, 2, 3, 4. Now it says they want it to be stable. How many neutrons to make it stable? You have a box of bones in your room. Oh my gosh, what kind of bones, Naomi? Hey, Ryder. How many neutrons to make it stable? Naomi's talking about bones. 5. Okay. 1, 2, 3, 4, 5. Okay. So what I got to do here is I got to make my crayon go small. Okay. And I'm going to put down, I have 4 protons, 5 neutrons. Now it wants a net plus 1 charge. How many electrons am I going to have to add to get that? Oh, deer and raccoon. Cool. Did you find those in the woods? 3 electrons. Oh, cool. Let's see if that works. 1, 2, and 3. Yep, plus 1. So we're going to write down here 3 electrons. Right? And now what we're going to do is we're going to draw the 3 electrons in. 1, 2, 3. Right? My mass number is the total of 4 and 5, which is 9. My atomic number is 4 for the number of protons. And we're stable. Okay? Right? So let's move on to the next one. Some reset. Put this one down, that one down. Okay? Hydrogen, notice that they have 3 particles in here. Let's see. Can I put protons in here? Uh-oh. What did I make? I made lithium. Okay, so I can't do that. I had to keep hydrogen, so it wants me to add how many neutrons then? Nope. Look at, there's 2 little balls here. I still have to be hydrogen, but I have to have 3 total. 3 total. Yeah, that's it, Raven. 2 more neutrons. Okay. It wanted it unstable, so it certainly is unstable. All right. So, and it wants 0 charge. How many electrons for 0 charge? So how many of these do I have to put in here? Get 0 charges. Plus 1 now. You need to have it 0. Yeah, that's it, Leiden. Yeah, there we go. So now what we're going to do is we're going to take the atomic number is 1. The mass is 3. It's unstable, has 1 proton, 2 neutrons, and 1 electron. Okay. All right, we're going to stop right there. We're going to do one more thing because I want to get this done because we're going to be gone tomorrow. We only got 10 minutes left. So let me do this. Let's close that out. Yes, get it. There we go. All right, my drive we'll go put over here and we'll get. So we're going to do assignment 1, W5 assignment 1. I'll give you that link there right here quickly. get that done before the end of the hour. So everybody can participate on this one. Module, okay, W5, assignment 1, basic atomic structure. W5, okay, so here we go. Make sure I'm giving you the right one. If it does, excuse me, if it doesn't go in, let me know. Uh-oh. I'm blacking out here. All right, here you go. Is this W5 assignment 1? Everybody got it? Tell me if you got it. And you can use your notes to do this. And I'll do it with you. Got it? Okay, Ryder. And anybody else? I don't want to leave anybody behind. Let's preview this. I want to do an edit. I want to show one question at a time so it doesn't show too many at once and it's a bigger screen. Okay? Bigger screen, bigger screen. There we go. So preview. All right, good job, Elroy. All right. Okay, first question. Yours might be shuffled. So what subatomic particle has a neutral charge? Write out the word for me, would you please? Write out the word. Proton, neutron, or electron? There we go, Stephen. Yep, and look at it's right there. Neutral charge, neutron. Everybody got that one? Can I move on? All right, at least right. Sabrina says yes, and so does Ryder. Okay, question number 2. What subatomic particle has a positive charge? Oh, you guys are on top of it for sure. Good job. Proton. Oop, I went pretty fast. Was that too fast? Should I go back? Anybody missed that one? I'll go back here a second. Question 2. Question 2 is a proton. All right, so let's go to number 3. What subatomic particle has a negative charge? Negative charge. Okay, electrons have the negative charge, right? There you go, Naomi. Yep, electrons have the negative charge. Neutrons have 0 charge, no charge, neutral, nada, zip. And protons have positive charge. Okay, question number, we only have 8. So which subatomic particle is not found in the nucleus? Not found in the nucleus. So look at this one, negatively charged particles found outside the nucleus. Oh my gosh, it is. Oh, there you go, Natalia. Thank you, Naomi. Thank you, Stephen. It's the neutron. No, it isn't. It's electron. Where are you, electron? I got mixed up. I got tongue-tied. So electron, four more to go. Thanks, Leadin. 4 more to go. Number 5. What subatomic particle is referred to as the DNA? DNA. Which one is the DNA? Look at that on the notes. Right there it says, yeah, proton. Remember, 1 proton is helium. No, 1 proton is hydrogen. 2 protons is helium. So every proton you add, it changes its identity. Where neutrons, you could add more neutrons, doesn't make a difference. Just makes it stable or unstable. 3 more to go. Which subatomic particle is the heaviest? Is it proton, electron, or neutron? Yep, you got it, Raven. It's the neutron. Everybody got that okay? We got 5 minutes still. We can slow down a little bit. Looks like nobody's saying, hold up, Mr. Gale. Hold your horses, Mr. Gale. Okay, we'll go to the next one. Oh, here's where we got to use the periodic table. Oh, no, Mr. Gale. Mr. Gale. No, 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 not the periodic table. Not that. Oh, no. All right, so we're looking for manganese. There it is, right there. Manganese. How many ons for man? Oh, you got it. You guys got it. 25. 25. Right, number 8. Okay, so which element has 29? Here it is over there. Hey, you guys have got it. So tell me what your grade is. Submit. Say, anybody need to go back? Anybody need to go back? Everybody got it? All right, Aquila. Good job, you guys. Thanks for your help. Couldn't have done it without you. All right. I'm going to stop the recording.